Good morning, students. So, we have been discussing the different physical properties of metals and non-metals in the previous classes. So, today we are going to discuss about the chemical properties of metals and non-metals. So, chemical properties of metals and non-metals. We know almost all metals, they have similar chemical properties, but the reactivity of metals vary. That depends on the reactivity of certain metals, that is the nature of the metals and also the reaction conditions. Based on the reaction conditions and nature of metals, its reactivities will be different. And let us take some of the chemical reactions of metals and non-metals. Now, the first one, reactions of metals with oxygen. Reactions of metals with oxygen. For that, in order to explain this reaction, we take magnesium ribbon. We know when we take magnesium ribbon, sometimes it is having dull appearance. So, first of all, we have to clean that magnesium ribbon with sandpaper. So, after cleaning or after rubbing with the sandpaper, you can see that shiny magnesium ribbon. So, for this experiment, we need what? Magnesium ribbon. Magnesium ribbon is needed. Then we also need Bunsen burner. Bunsen burner, you know, that flame Bunsen burner is needed. Then watch glass is needed. Watch glass, and then red litmus paper. Red litmus paper, and some amount of water. Some amount of water is needed. So, and also forceps, forceps to what in order to burn magnesium to the flame, we need forceps or tongs is needed. So, first of all, we take magnesium ribbon. First, you rub with the sandpaper. Then after that, you show this magnesium ribbon by holding with the this one. Forceps, and then shown to the flame. Then you can see that magnesium ribbon, it will burn with dazzling white fumes, and after burning you will get ash of burned magnesium, and that burned magnesium we collect in a small watch glass, and then you pour a little amount of water into that. Then after that you rub it, you dissolve it. Then you take a red litmus paper and dip in that red litmus paper in the watch glass containing burned ash of magnesium. And when you take out that red litmus paper, that red litmus paper changes into blue. So, which type of or what type of solutions turns red litmus paper blue? That will be a basic solution. So, here what reactions are happening? What are the reactions happening in this case? Magnesium ribbon and reaction with the oxygen. So, we are burning magnesium ribbon. So, magnesium, the symbol of magnesium is Mg. This is the symbol of magnesium. Magnesium, it reacts with the oxygen. Oxygen, the symbol of oxygen is O. Here we take O2. Okay, the symbol of oxygen is O, and then O2. We are taking O2. Then we get what? We get magnesium oxide. So, this is the reaction is happening between magnesium and oxygen, or magnesium when it burns in air, we get magnesium oxide. and this magnesium oxide, that is the ash, that we get ash, and that ash is called a magnesium oxide. When we dissolve this magnesium oxide or ash in water, so magnesium oxide, its formula is MgO. This is the molecular formula of magnesium oxide plus water. Water, the symbol, you know what is the formula of molecular formula of water is H2O. We get magnesium hydroxide. Magnesium hydroxide, that is Mg or H2. This is the molecular formula of magnesium hydroxide, that is magnesium hydroxide. We get magnesium hydroxide. You also studied in your lower classes magnesium hydroxide, whether it is base or acid, whether it is base or acid, hydroxide. So, magnesium hydroxide is a base. So, here magnesium is a metal reactive to oxygen, it forms magnesium oxide. So, this is called a metal oxides. This is called a metal oxide. Here the metal is magnesium. When oxides are formed with metals, that is called metal oxides. Here it is magnesium oxide. So, metal oxides are, when it dissolves in water, it forms hydroxide. Here it is magnesium oxide react with water, it forms magnesium hydroxide. So, metal oxides, here also magnesium oxide. What is the nature of metal oxide? Metal oxides are basic in nature, because when metal oxide dissolve in water, it produces metal hydroxide. Here it is magnesium hydroxide. So, metal oxides are basic in nature. How can we prove that how the metal oxides are basic in nature? You can do this experiment. When we burn magnesium with oxygen, it forms magnesium oxide, and that magnesium oxide, when we dissolve in water, it produces magnesium hydroxide. And we can test whether it is acidic or basic using the litmus paper. When we dip red litmus paper in this magnesium hydroxide or metal oxide, we get that is red litmus paper changes into blue. It means metal oxides are basic in nature. Metal oxides are basic in nature. Okay. So, generally we can write that metals react with oxygen, it forms metal oxide. Metals react with oxygen. So, metals react with oxygen, it forms metal oxides. Metal oxides or metal oxide. Then these metal oxides, they are basic in nature. So, metal oxides are basic in nature. Metal oxides are basic in nature. So, you can take another example, rusting of iron. Have you heard about rusting of iron? When we keep iron instruments or iron materials, when we expose to damp air, so damp air means that contains slight amount of water vapors. So, when we expose iron materials in damp air, we can see that after a few days or after few months, you can see that it is corroded. It is corroded, or you can see that reddish brown flaky substance that is formed on the surface of the iron materials. Reddish brown flaky substance that is formed on the surface of the iron materials, and we can take it out. And then you dissolve in it water. Take some amount of this flaky substance, reddish brown colored flaky substance, that is called rust. And these flaky substances, when we dissolve in water and then you check whether it is acidic or basic using these litmus papers. So, here also you can see that red litmus paper changes into blue. So, what is happening here? What is happening in the case of rusting of iron? That is, iron when it exposed to air, iron react with oxygen, that is oxygen in air, in damp air. So, damp air means that also contains what? Water molecule. Damp air means what? A slight amount of water molecules will be there. So, air also contains oxygen. So, iron react with the oxygen and water molecule. It forms hydrated iron oxide. It forms hydrated iron oxide. This hydrated iron oxide is called rust. That is called rust. Hydrated iron oxide is called, or it is hydrated ferric oxide or hydrated iron oxide, that is called rust. Okay, that is called rust. So, this rust is, it is hydrated iron oxide. It is an oxide form of metal. So, when we dissolve this hydrated iron oxide, it is having reddish brown color. It is having reddish brown color, and this reddish brown color flaky substance, because when we rub with that substance and when we dissolve in, take small amount and then dissolve in small amount of water and then shake it well. After that, when you dip a red litmus paper, you can see that red litmus paper changes into blue. So, this is also indicating that iron oxides, here also hydrated means they contain water molecule. Iron oxide contain water molecule, that is called hydrated. Hydration means hydration means added water molecules. Water molecules, that is iron oxide contains some amount of water molecule, that is called hydrated iron oxide. So, here also iron oxide means it is also a metal oxide. So, that metal oxide is also basic in nature. So, metals react with the oxygen to form metal oxide, and these metal oxides are basic in nature. They are basic in nature. Okay. Then take another example. We know when copper materials or copper utensils, when we keep it for longer period in damp air, when we keep copper materials for a longer period of time in air, in damp air, you can see that there is a green coating on the surface of these copper utensils or copper materials, or copper it get tarnished. Copper loses its shiny appearance and it is coated with a green coating. So, here what is happening there? That is, we know copper, the symbol of copper is Cu. Copper react with the air contains what? Oxygen, then water, and also it contains, so copper react with the oxygen, then it also contains what? Water molecule. Damp air may contain water molecule, also it contains carbon dioxide. Carbon dioxide. So, copper react with oxygen. This is the symbol of, I am writing here below, I am writing the symbols. Copper reacts with oxygen, then plus water plus carbon dioxide, that is CO2. Then what we get? So, we are getting that a green coating on the surface of copper materials, and this green coating is that is called it contains a mixture of copper hydroxide, plus copper carbonate. These two is due to that is the green coating. The green coating on the surface of copper utensils or copper vessels is due to the presence of copper hydroxide and copper carbonate. I am writing the symbol, the formula. Copper hydroxide is CuOH twice, and here CuCO3. Okay. This is what is happening when copper material is exposed to damp air. It reacts with atmospheric oxygen and water molecule and carbon dioxide. It produces copper hydroxide and copper carbonate. Mixture of these two is responsible for the green coating on the surface of copper materials, and this is also called basic copper carbonate. That is together we are calling them as basic copper carbonate. So, the green coating is due to the presence of basic copper carbonate. Okay. So, basic copper carbonate, why it is called a basic copper carbonate? It contains copper hydroxide. So, copper hydroxide, it is also basic in nature. So, metal oxides are basic in nature. So, these are the some of the reactions of metals with oxygen. So, these symbols, when you study these symbols, it is very useful for you in because you are all studying this in higher class also. So, along with the these copper, oxygen, when you are studying the symbol, it is very useful for you in higher classes. Okay. But it is not necessary to study all these things, but when you are studying, it will be very useful. Okay. So, these are the reactions of metals with oxygen. So, metals react with oxygen, they form metal oxides, and these metal oxides are basic in nature. And so, these are the reactions of metals with oxygen, and you might have an experience that when we expose silver ornaments or silver substances in air for a longer period, you can see that the silver get tarnished, or you can see that silvers, there is a black coating. Can be seen on silver. So, why this black coating? What is the reason for this black coating on the silver substances? The reason is that is silver react with hydrogen sulfide in air. Silver react with hydrogen sulfide in air. The silver Ag is the symbol of silver. It react with hydrogen sulfide H2S, that is hydrogen sulfide. It forms silver sulfide Ag2S. It forms silver sulfide, that is Ag2S. These are the symbols. You can also study this one. It is not necessary. So, it forms silver sulfide. This is the symbol of silver sulfide. Okay. That is Ag2S, silver sulfide plus H2 plus hydrogen plus H2. So, that black coating on silver materials or silver ornaments is due to the formation of silver sulphide. Okay. So, here it is that why the silver materials get tarnished, that is due to the formation of silver sulphide, that is when silver material is exposed to air, it reacts with the hydrogen sulphide in air and it forms silver sulphide plus hydrogen. So, this silver due to the formation of silver sulphide, they are there is a black coating on the surface. Okay. So, this is the reactions of metals with the oxygen. Okay. That is all. So, we have discussed the reactions of metals with the oxygen. So, metals react with the oxygen to form metal oxide, and these metal oxides are basic in nature. Okay. That is all. Have a nice day. Thank you.